Here's a real challenging problem. They give us this rectangle and they tell us we have a measurement of 2 and 8, so we know each corner is 90 degrees, and they want us to find where the diagonals intersect. They want us to find this x degree opening. They want us to find that measurement. Now the first thing I think of when I see a right triangle is I'm thinking, oh, Pythagorean theorem, they give me two sides, I can find that hypotenuse. But that's not going to really help me find an angle measurement in this situation. So I have to start thinking, well, okay, it's a rectangle. Well, the special thing with a rectangle is diagonals are exactly equal in length. Now the other nice thing is they bisect one another, as all parallelograms do. So basically this leg and this leg and this leg and this leg are all exactly the same length. Now that tells me that this leg and this leg in this triangle are exactly the same, which then means the angle down here and the angle down here must be the same. So if I somehow could find the angles, one of these angles down here, the other one's got to match it, and therefore, let's say we're, maybe 70 and 70, that would be 140, so that'd have to be 40. If I can find these, I can figure out what x is. So the question is, how can I find these? Well, notice we have a nice big right triangle right there. Let's redraw it a little bit. How can I find theta there? Knowing that that's 90, this is 2, this is 8. Wait a second. That's where my trig functions come into play. This is where I have that some old hippie called another hippie tripping on acid. And I'm trying to find this theta right here. Well, I have the opposite side right here, and I have my adjacent side right here, hypotenuse there, but we don't have a measurement, so it doesn't matter. I have opposite, adjacent. Looks like I'm going to use the tangent function. So I have the tangent of the angle is equal to the opposite measurement, 8, divided by the adjacent measurement, 2. So I have the tangent of theta equals 4, basically. Well, what am I going to do? Sit here and just plug in numbers into theta to figure out and keep hitting, like 60 degrees, tangent of 60, and see does it equal 4? No, what we do is the way we are told to get rid of the word tangent is take the inverse tangent of this side and take the inverse tangent of here. So theta is going to be the inverse tangent of 4. When I put that in the calculator, theta is going to come out to be right at about 76 degrees. So I now know that in this picture, that's 76 degrees, that's 76 degrees. Well, those add up, 76 and 76, that adds up to 152 degrees. Triangles must add up to 180, so I have 28 degrees to go here. That means that x right there is going to have to be 28 degrees. Very difficult problem, but if we just simply start with what we know, knowing, hey, how am I going to find that? I'm having to try and find an angle. I start realizing, oh, well, maybe I need to look at these corners because they're going to be the same. Then it leads me to this picture, and I have to use basically my trigonometry functions to help me.